Alright, but that's not all. The interesting is that the dimensions themselves are cyclical. Okay? So we start off from nothing, go end up to first, second, third, fourth, fifth, and infinite dimension. And then, from infinity, we'll go all the way back to zero and start again. So why is that? Well, if you remember in my previous videos talking about shapes and so on, you notice that when you're starting from a dot and we add more points, more from a straight line, then to a triangle, to a square, and so on and so forth, you end up getting to a circle, right? If I were to zoom out far enough from this is going to end up looking like a dot. And then we know from a dot I could work my way back to a circle. Go on. So essentially this is ends up being the same thing, right? Infinity will eventually lead you to zero because they're practically very similar, and so this whole cycle begins again. Okay, here's another way that I like to draw the representation of the dimensions. Okay, so in this dimension, now we can travel these directions. This dimension adds this form of travel. This dimension adds this form of travel. This dimension adds that form of travel. And this dimension adds that form of travel. So that's an interrelation of the dimensions. Okay, so to sum it all up, now this is going to look very familiar to you. Alright. This is going to be our first dimensional object, represented by a dot. Moving to the second dimension, I add another dot. Draw my second dimensional object as such. I could have drawn it straight through, but for the purposes of tying up all the dimensions, I'm going to draw it in such a way. Now, the third dimensional object is going to end up looking like this. Moving out to the fourth dimension, I'm going to draw it as such. What I'm going to do now is color that in. And essentially what those colors represent is the passage of time, or time as seen in the third dimension. Okay, so as this, I will call it, this beach ball rotates, it's just showing that the changing of colors is the changing of the time as seen. So I hope that kind of makes sense. So that's the fourth dimensional object. So to draw the fifth dimensional object, I would draw it as such. going in parallel. Well, that's a horrible circle. Where here we have parallel universes, and they're not necessarily one bigger than the other. Some could be the same size, some can be smaller, but they were all parallel. And what I'm trying to say is that this universe may have a starting time. So this is what I mean by this universe right here. That may have a starting time of here, and this universe may have a starting time of here, and this universe, the one we're in right now, may have a starting time of here. That these two may not, well, although they had the same starting times, the whatever happened here might be slightly different than what's happening here. And so this universe probably has a starting time here. So those are the parallel universes to this one, which is our own universe. And each one of these universes are also going to have their own little beach ball, their own little points, so on and so forth. Okay, so I would draw that like that, and then so then color that in, and color that in, and color that in, and then continue on from there. Okay, so that's in a nutshell. Those are the 5 dimensions. And if beginning, this was blank, so there needed to be nothing in order for this to occupy the space for it to be something. And then eventually it's going to reach infinity. So after the 5th dimension, you have reached infinity, because you're going to encompass all possible, all possibilities, I should say. Therefore, you've reached infinity, okay? Okay, and lastly, this goes to help support a theory that exists, and it pretty much says that right here is the starting point of the Big Bang. So then the universe expands really quickly, then it kind of tops out and stops to decay in terms of its expansion, right? And then it starts contracting at the same rate as it was expanding at first, and starts slowing down, and then eventually all the objects in the universe get really close together and create another Big Bang again, and then this happens all over. So this is in the 3 dimension. This is the objects in the 3 dimension trying to, space itself, trying to expand and reach to infinity, but it's unable to. And during this expansion here, it's going to get really cold. Well, I'm not going to say really cold, but as space moves further apart, it's less dense, so there's less molecules closer together, therefore it gets colder, and here it starts to get warmer, and molecules are closer together, so it gets warmer, and then eventually they get too close and it gets really hot, and it all happens again. So that's the cycle in the 3rd dimension. Well, of our universe and of every other existing universe. And so that's that. So how would this be helpful? Okay, so I guess the first dimension we'll start off with will help us explain or discover things related to anti-gravity and black holes. Okay. We were in the second dimension. We've covered a lot of this already in terms of communications and power. Third dimension, well, I'm not going to write much for that because we already exist here, so that's normal for us. Fourth dimension, put here time travel, or wormholes. Fifth dimension, traveling across parallel universes.